Welcome, everyone. We are at the SMAC number 21st, I think. This series of talks about computing and astronomy and computing and all related to software. Today we enjoy a talk about Slurm by one of our best men, our own Ángel Vicente. If you are being in many of these seminars of the series, you are for sure familiar with him. So please, Ángel, welcome and take it on.
Thank you, Carlos. I will try to remember to talk on the mic. This is going to be difficult all the time like this, but anyway. Yeah, so as Carlos said, the talk today is just an introduction to Slurm, basically because here at the IAC we have used Slurm for many years actually, but mostly in LaPalma, in the supercomputer, and also in deimos and diva, this big machine that I will bought with several money. But now lately we are also introducing Slurm in the burros, in the public burros and in the private burros, whoever wants to install it there. So then we decided that it would be nice to have a talk on Slurm to introduce how it's used and what we are planning for the burros, and just to make sure that possible users will know how the system works. So for introduction, if you don't know Slurm, I guess most of you know already, but in any case, it's an open source, fault tolerant, highly scalable cluster management and job scheduling system. So basically, before it was called Slurm, like simple Linux, stands for Simple Linux Utility for Resource Management. And here, now Slurm is a combination of two things, job scheduler and resource manager. Okay, resource manager basically is when you submit something to a queue, is the part of the system that takes care of making sure, for example, which that you don't overuse the machines, that you can actually access to those machines, etc. And the job scheduling is the one that actually, when there are many jobs, the one that is going to put some order in to make sure which one goes first and etc. Right? So Slurm basically started as the resource management part. If you are old enough, you will remember that here at the IC at some point we have something like Maui and Torque. So Torque was the resource manager, so that part that takes care of the resources, and Maui was actually the job scheduler. When you have many jobs, Maui will decide which one will execute first, which one will come later, etc. And Slurm now these days does both things, but actually from the user point of view, we are only interested in job scheduling. The resource management is basically transparent to you, so you don't have to care about that. But the job scheduling is the interesting part, so that's what we will discuss here. Basically, Slurm is used in many places worldwide. If you look at the top 500 supercomputers, at least this is from 2019, I don't know today, but it was used in 60% of them. If you have used PISDYNE, for example, it's used in all of their machines, all of the CS machines. In Mare Nostrum as well, all the systems that belong to the rest use Slurm, and it's used everywhere. So if you plan to use any supercomputer at any point, basically knowing how to use Slurm is a good thing. Here at IAC, and LaPalma has used Slurm since I remember. So, well, I put all the links here, and I will make available the slides later somewhere, so you can also check there. But I put here all the links to the documentation of most of the things that I will talk about. In deimos diva, that's if you don't know, this machine is one that has well, deimos has a GPU, and it's like a login node for diva that has 192 cores. And I don't know how much memory, 4 terabytes, something like that. That's quite large. So that system also uses Slurm. And now lately, we have the burros, which are basically high-performance Linux PCs. Some of them are public, and some of them are, well, they belong to a particular project. And we are installing Slurm in the public ones, and also in the private ones that ask for it. So far, we are trying to do it gradually, so not all the burros have. We have installed only in a few of them to make sure that everything works okay, to see what the feedback we get, and then later we'll progress to all of them. So, I mean, in case somebody thinks that we don't maybe need this level of complication, I mean, in supercomputers, we always need a workload manager basically, because for parallel jobs, you normally need actually a dedicated access to the node. Okay, otherwise, if somebody's accessing the same node as you are, one of your processes is going to go much slower, and then the performance of the whole program can suffer a lot. So normally in a supercomputer, you get a dedicated node, and obviously to manage that, either you do it either through reservations, which is much more cumbersome, or you do it through a system like a Slurm. Normally, you use something like a CAT. So you have a competitive call, you make a proposal, and depending on the merit of the proposal, you will get a number of computation hours. Okay, so that makes things easier somehow in the supercomputer. But in the burros, and later also in deimos and diva, the main issue is that we don't have a single node. No, sorry, the main issue is that basically the whole burro is just like a shared single node. So a lot of users will try to use just one machine. There is no cut, because there is no point in actually trying to decide who is going to use the burro based on any merit. So anybody can basically use the system. And the problem that we saw is that without the scheduling system, it was basically a mess. Okay, everybody will log into the node and then start executing whatever, and people was not careful to actually check that the machine was not being used by other people. So there would be maybe 30 cores, and there would be 60 processes running full time, and then the whole thing actually goes much slower than it should. Okay, I don't know if I just put this figure here. I don't know if people sometimes just ignore it by accident or whatever, but I mean, normally Linux will obviously take as many processes as you throw at it, but what it does is just multitasking, and obviously it's not magic, right? So even in case you have only one CPU, you can execute 3 tasks, no problem. It will give you the impression that all of them are running at the same time, but obviously the CPU has to make slices and give a little bit of time to each of them. And so at the end, all of them suffer. All the tasks will finish slower than if you actually submit each one sequentially. And that's what was happening in the burros. A lot of people will go there, will make everybody slower, and actually, well, sometimes you will not, I mean, the whole machine will just almost even crash because you will just run out of memory, etc. So then, if you are convinced that we need a Slurm, so then we have to learn how to use it a little bit. At the IAC, we have some resources for documentation and support. You can follow these links. I mean, here we have, for example, let me open, let's see, yeah. So we have a documentation page like this where it will show how Slurm is used and some examples of how to run different type of codes, whether it's a Python script or MPI applications or MPI or whatever, okay? So that's, oops, sorry. We also have, I mean, if you follow that same page, we have a specific information for some of the resources, for example, for LaPalma, because each of them will, even if it's the same system as Slurm, it will be a little bit different because each one can have different queues or different queue configurations, etc. So we have to put that as well. And also, well, if you use Sulipat IAC, we have a stream that is specifically to discuss things related to Slurm. So also for, I mean, if you want to start using Slurm and you have never used, I mean, basically with these 5 commands here, probably you are okay. I put a link here to actually all the details. You are going to forgive me if I don't go through all the details, because, for example, if we go to this one, SBatch, the documentation, you can see that it covers some ground here, so we're not going to go to all the details, okay? But I mean, the idea is that these 5 commands, and actually probably the most important ones are just 2 of them, probably is enough to start. So the sinfo is just, it will be the basic command to view information about the queues, because we're going to configure the system that we can have a number of queues, and we are going to be able to decide what is the length of each job that can run in there, etc. Things like this. Then we also have SQ, just to see the information, well, to see which jobs are in the system, either running or waiting to be executed. Then obviously scancel will be to, if you make a mistake, you can cancel that job. And then the two important ones probably are sbatch, that's the one to submit a job to the system, and salloc. This one is mostly used for interactive, when you want an interactive session. Okay, so I put just some examples here, but obviously, I mean, either in our local information pages or in the official Slurm pages, there are plenty more details. So for example, if you go to any of the machines that have a Slurm and you want to see the information about the queues, you can run sinfo. This is, I just put, there is an option to actually decide what type of information you get. This one is a bit more complete than what you get only with sinfo, but it will tell you, for example, the number of sockets, core, and threads that the system has, the number of partitions. Slurm calls partition for what we would call queues. And then, for example, you can get how many CPUs per node you can, well, how many, yeah, in this case, how many, the maximum number of CPUs that you can run in this queue. And also important, obviously, the time limits. Okay, this is 2 days, 4 days, and 14 days. So that's just in case you go to a new machine and you want to see what are the queues available, so you can use SIM. SQ is you use it all the time as well. If you want to see what's in the queue, so for example, in this case, there were only 2 jobs here, and it gives you some basic information about how much time has been running, how many nodes it has used. This is output from LaPalma, the state that is running, and also who is the user, etc. Okay. And scancel is the one that, well, just you take a job ID, you take the number there, and if you want to cancel a particular job, you just give that number. You can also, I mean, obviously there are many more options that I'm not going to go, but you can cancel, for example, all the jobs of a particular user. Well, normally only your own jobs. If you're admin, you can do more things. You can cancel all your jobs or etc. And then, so the other 2 commands that are the important ones are sbatch and salloc, as I said. Then I'm only going to show one example here just to get an idea, but either in any of these 2 links, you can get more information about that. Well, this is the one that I just saw, some examples of, so for example, this is a particular type of batch script that you could use for OpenMP or for MPI, etc. And so I just put here the most basic ones. Okay, the idea is always that it's just a regular test script that normally you would put here what is called the shebang for bash, and you would put here what is going to be executed, and then with this sbatch comments, you specify all the options for Slurm. So in this case, for example, this one is quite simple, but many times you just need something like this. So you would say, for example, I just want to run 4 tasks. I just want 15 hours. Then you can give the name of your job. This is what it will show when you see the queue. Then the name here. Okay, so if you have many jobs, it's nice to have a name there to differentiate which job you run. And then you can also say, for example, where the output and the error information is going to which file. Okay, so in this case, for example, you put the output %j.out. So basically, this will be the ID of the job. I mean, it will be when it's written to the file, it will substitute this by the name of the job ID, and then to that file. So the idea is that you will need basically, unless you want to run something interactive, you will need to write a small script like this with some details of what you are asking, what sort of resources you are asking, and what is the application that you run. Okay, and then when you want to submit it to the queue, you just have to issue sbatch command, and then that will go in the queue. If there are people who use MPI, which I assume there will be, then also, I mean, it's important to note this will be more complicated, so I don't mention it here, but you can do more advanced MPI task placement. So you can decide exactly if you want, for example, that the tasks are spread, for example, task 0 to first node, task 1 to second node, or you prefer to put all the tasks together in the first node until you exhaust that one, and then you go to the next node, etc. So you can do complicated things with that. So this would be for non-interactive jobs. For interactive jobs, you can also use this in LaPalma, but it's more important for the burros, as we will see. There is one command, salloc, that it allows you to run an interactive session. Okay, so in the burros we have a wrapper to make this one look nicer, but in LaPalma, for example, you will use something like this. So you're saying, I want 4 nodes, and I want to run basically bash. So then when you run this, you will just get a regular session, but then that one is an interactive session handled by Slurm, and then you can run any command there. It's useful if you are debugging, or in the burros, for example, it's useful to run interactive sessions to run graphical codes, etc. So then if we go to a specific to LaPalma, which is the one that uses Slurm for longer, I guess. If you don't know LaPalma, well, this is a part of the rest, the Red Española de Supercomputación. It has 252 nodes, and each one has 16 cores. And then 50% of the time is reserved for IAC. And this one, well, in this case, there is a login node. So you submit all the jobs from an external machine. You don't have access to the compute nodes until allocation. When you get an allocation and you start running something, you can SSH to those machines to see that everything is working okay, etc. But until you get the allocation, you cannot access any of the computer nodes. And the minimum allocation unit, so the minimum that you can ask, it's a node, except for very small jobs, okay? But normally, each node has 16 cores. But so, for example, if you ask for 20 cores, the system will give you 2 complete nodes. No, not 16 cores in one and 4 in another one. It will not share that node with anyone else. Okay, so you have exclusive access to the node, and that makes the whole thing for Slurm much easier, because you don't have to share the system, the node with anyone, so you don't have the problems or the difficulties that we're going to have with the burros. And so in Slurm in LaPalma, I mean, there was because the resources are scarce, so there's always a problem of people maybe thinking that the system is going slow, that their jobs are not executed quickly in the machine, etc. So we have recently made a couple of improvements to try to be more transparent about the queues, and hopefully that way the users can plan their executions and get all the information about the queue easier. So one is a dashboard that you can access here. Let's see if it works live. Yeah, okay, so this is the live dashboard right now. Okay, so it's useful, for example, it only has a few panels of information, or at least the user one, the public one, but it's useful in the sense that you already see quickly, for example, that now 96% is being used, and there is 146% of oversubscription. So there are jobs there that they are in the queue, but they are not being executed. So this is useful to see, for example, whether it's a good time to submit jobs, or maybe you better wait, etc. Another thing that we have, normally if you use the command SQ in LaPalma, you will only see your own jobs, but then it gives you the impression that there can be very few jobs, and maybe actually there are thousands of jobs waiting. Okay, so we wrote a little script. It's called SQ all. that will give you information like this. It will not show you who is the user that is running this, but it will tell you the job ID and the time limit, etc. And the most important thing, the priority. So with this, the idea is that if you check your queue and you know your job ID, then you can check with SQL in which position your job is. So if you submit one job and then you realize that there are 2,000 jobs ahead of you, before you, then probably maybe you want to go to another machine or change the parameters or the limits or whatever. But then at least this will give you some indication of how long you're going to have to wait until it's executed. And then also, I mean, we're planning to make some changes in LaPalma, for example, to improve the time that you have to wait for debugging jobs, etc. But because in LaPalma, it's not only for IAC people, it's also for external users. We have to be more careful because this configuration changes will also impact the external users. So then we are making all the changes first in the burros, and then if it works okay, then later we will move it to the rest as well, to the LaPalma. Okay, but this is just the dashboard. And so the Slurm in burros, which is basically the main motivation for this talk somehow. So the idea is that in burros, it's much more complicated to have something like a Slurm. First thing is because we don't have a login node. So the login node basically allows that nobody's running things in the compute nodes without the control of the Slurm. But if there is no login node, anybody that logins through SSH to the node could actually submit anything and then basically bypass the Slurm. Okay? And also, so that's one difficulty. And the other one is that everything is shared. It's a shared resource. So, I mean, we could make it that once you connect to the burro, then the whole burro is for you. But we don't have many machines. So if we do that, then we will have a problem of people not having access to computers. So we have to try to make that the node is shared among different users. So you have to make sure that somehow that is shared fairly. And so, well, yeah, the minimum allocation unit in burros is the CPUs. In LaPalma was a node. So once you get a full node, that's your responsibility what you do with it. But here the minimum allocation unit is it's a CPU, whether a core or a hardware thread. Let's not go into that. But so you can get, for example, if a burro has 32 cores, you can maybe just want to get 4 cores, and somebody else, then the system has to be able to allocate the other 22 to other users later, okay? And that's more difficult to check with, to configure with Slurm. And also, the most basic one is to care about CPUs, but we also have to care also about memory, for example, GPUs, etc. Okay, we have more resources, and it can cause a problem that different people use the same resources. Then we have to be able to share those ones with Slurm, and I will show later how we do. So the first thing is what I said, that there is no login node, so we need to restrict how you use interactively outside of Slurm. So what we have done is that we use cgroup, which is a technology used, for example, in containers, so that when you connect through SSH to a machine, to one of the burros, you only get the equivalent of 3/4 of a CPU. So if you try to run anything heavy, it doesn't matter. I mean, if you try to submit something that requires 20 CPUs, it will tell you that it's giving you 20 CPUs, but the whole overall consumption that you're doing is just like 3/4 of a CPU, very small. So you will realize very quickly that the machine, there is some problem with the machine. Well, there is no problem with the machine. It's just that you need to use Slurm. Otherwise, you are restricted to a small processing unit. And it's working fine now. But this is, I mean, part of the motivation of the talk as well is just to say that this is work in progress. I mean, we're making these changes as we go along and we learn. if anyone has problems with how it works, suggestions of how to improve it, then that's the plan of this talk. We can change it either now or during the next weeks or months to make it the best possible system and that we can make. So with the burros, we have some basic queue configuration. Okay, that if you go here, well, it will explain there the details of how many queues there are and etc. and how they are distributed, etc. But basically, I mean, for now, probably just enough to say that we have two partitions. So one will be a batch for longer jobs, 2 days, and an interactive partition for 8 hours. The idea of the interactive partition is that anybody can, if you need to run some graphic program or debug or write code and compile it, and you need some interactive session, you can use the interactive session basically the same as you would use the machine without Slurm. The only thing is that you have to think get an allocation in advance. So we made this sinter wrapper. So it's very simple to use. You just would say, for example, sinter. This will mean that you want 10 cores, and then this means that you need 1 hour of time. And this will put you in a session like this. We make it, put this in front of the $sign, just to remind you that you are in an interactive session handled by Slurm. And then in there, you can run any command, like if you run when you connect through SSH normally. And so this will be the common configuration for the public burros. But the project burros, I mean, we already have, should I say project donkeys? But so for the project burros, we already have, I think, four burros belonging to a particular project. And in those ones, I mean, if you need to install it there and you need a special configuration, it's no problem. I mean, you can change the queues, the length of the time limit of each job, etc. And so in public burros, we also put in here in this page, we put the information on, because you need to get an account in a Slurm, otherwise you cannot submit jobs. So in here we put instructions of how you can auto-generate an account in the public burros, but in the private ones, obviously you have to contact the PI to get access. And well, this is probably not of interest to users, but all this, we are making it available through a multi-cluster configuration. So otherwise it will be a nightmare if we have to install a Slurm. Well, we still have to install a Slurm in every burro, of course, but if we have to administer from every one, it will be much more difficult. So we use a multi-cluster configuration that has a centralized database. And then, so for example, from any of the burros, we can use a command like this. So we specify which of the burros we are interested in. And so in this case, we can see the queues automatically for all the burros. We can change the configuration for all of them. And so it will make my life easier. Okay, I don't have to connect to every individual. But well, that's basically my concern. It's not for users. So then, the idea of this talk as well was to actually give users some tips or some idea of how a Slurm works, because if you understand at least not how it works internally on all the only the part that takes care about job scheduling, because if you understand that, we can make sure that the whole system is better. It has a better utilization, and also your jobs can actually get faster in the queue and execute. Okay, so basically what I was going to cover here is some information about job scheduling that I hope it will be useful for future users to understand how to make the best usage of the system. So the queues that we are going to install in a Slurm, I mean, to make a good use of the system, basically it requires a couple of things from admins. We obviously have to configure them properly with good time limits, etc. And for that, we have to understand what type of workloads we are going to run in the system. Okay, it's not the same if everything that we're going to run is sequential jobs or very large parallel jobs or whatever. So we have to understand that, and we have to monitor what type of jobs are being executed. And for users' point of view, sometimes people who haven't used Slurm or a queuing system before, they try to be very respectful to others. So I'm not going to submit my job because I see that there are a lot of jobs, etc. Actually, that's counterproductive. Okay, so I think that for users, the best is to try to be selfish. You have to assume that the machine is only yours. You submit whatever you need, and we should worry about making the system fair. Because if you submit really what you need, not taking into account other people, you can actually see what is the load that the system is going to get, when, etc. So we try to be, in this case, it's good to be selfish, okay? And then it will be nice to have some understanding of how the system works, and that's what I'm going to explain after that. And well, in LaPalma, for example, when you have something like a cat, so you have a committee that actually gives some the amount of time that you can use the machine for, makes things easier. But in here, we're going without a system like that in burros, we will need to use something like Ferser that we're going to see later. And our job actually is going to try, nobody's going to be satisfied, so our job will be to try to make everyone equally unsatisfied, more or less. Okay, if nobody complains more than the others, then we're doing a good job. So the first type of queue that you can imagine, I mean, this is the most simple one. It's just a FIFO, right? First in, first out. This is like your typical supermarket queue. So these are the processors here, and the jobs come. This has been waiting for a long time, and it's executing now. This is another job, and these ones come later. Now, this is not very efficient because it can leave many resources unused. So for example, here now this guy is executing here because this one has come later, is waiting, and then these ones have no chance of executing, okay? And it's going to leave many resources unused, and also it doesn't guarantee any fair use. If you come and submit 1,000 jobs, then your jobs are in the queue. If it's just first in, first out, you're basically going to hold the machine hostage for I don't know how many days. So then there are many improvements over this, and we're going to see some of them in the next slide. And there are three main important concepts that we're going to try to focus: time, CPU, and memory efficiency, okay? And with that, we're going to, the idea is that we will try to improve the usage of resources for everybody. So the first improvement that we can think is what is called backfill. The idea is that even if a job has lower priority, you can let the system, you can let them use empty slots. So if you remember, these two jobs were here waiting, but because how tall they are, it represents how the time limit that they ask for, right? So assume that this is, for example, 1 day, and this one is 2 days. So these guys are asking for 1 day, and actually there is an empty slot in there. So even if they have lower priority, they can jump in here, and they can execute. So this is what is called backfill, and the system is doing constantly. But then the time efficiency, one of the important concepts that I mentioned, how close the requested and the actual job times are. So the time efficiency is very important, and let me show you a couple of examples why. Many people actually, for example, when they submit jobs, they don't want to change the time that they ask for. So they say, okay, what is the maximum time limit? In LaPalma is 3 days. So I leave always 3 days in the batch script. I say always that I'm going to use it for 3 days. And then even maybe my job actually, I only requires 1 hour, but I just leave it always like 3 days. And that's a problem because, for example, in this case, this guy, if I say, for example, assume that this is 2 days and this is 2 days as well, these two cannot backfill here because the only empty slot that is remaining here, it's 1 day. This is the job that is running now. So if you say that you need 1 day, it could start executing here. But if you always leave a very long time, they are not going to be able to backfill. So in this case, this goes against you. I mean, if you don't try to make the requested time as close as possible to the actual time that you need, then the system is not going to properly use backfill. And also the other situation can happen as well, okay? Imagine that here there was a job executing that it promised that it was going to use 1 day. So if you had these 2 jobs here waiting, they can backfill. But now what happens if this one, instead of taking 1 day, finishes in 1 hour? Then suddenly there is a big gap here. Slurm is not going by default to kill any job. So these ones have entered the queue. And now this guy that was that had higher priority than both of them, it's going to wait. It's going to have to wait until they finish. So then in this case, you are actually making the whole system work worse, because this guy here, instead of 1 day, it should have said that it was going to take shorter time. So that's why time efficiency is important. So it's important that if you are going to submit something, you try to get an idea of how long it's going to take. Obviously, if it's going to take 3 hours, you cannot put a time limit of 3 hours very close to it, because then if you go over it by a little bit, the job will get killed. But you can get a margin of 50% or something, but not take by default to always put the maximum limit of the queue, because that goes against the whole system. There is also one interesting thing with Slurm, that the priority calculation is done based on multi-factors. Okay, and there are several factors that can be used. This is a list: age, first serve, job size, etc. We're going to concentrate only on the first 3: age, first serve, and job size. Age basically is what we already saw. This is sort of the FIFO. Okay, so if your job has been on the queue longer than the others, then it has more priority. And then first serve and job size are important. Okay, and then we're going to cover them later. If you are in a machine with Slurm, you can use the command sprio, and this will show you for all the pending jobs, it will show you their priority, and it will also give you the different factors and their values. So for example, in this case, there are 2 jobs. Their priority is 46,000, 27,000. The higher the priority, well, it means that it's going to run in principle before the other one. I'd say in principle because backfill could happen, okay, but in principle it's going to run before the other one. And then you can see the individual contributions of each of the factors. So for example, this one, 9,000, it has been longer in the queue than the other one, but this one has a bigger first serve, for example. So you can analyze why your job, for example, has a lower priority, etc. like this. There is more information here in priority multi-factor. And first serve is basically the idea that it's going to allow users who have not fully used their resource grant to get higher priority, while making sure that those users that have used more than the resource grant do not overuse the cluster. So basically, the idea is that unless I configure it in a particular way, where the system is going to try to make sure that we use the same amount of hours in a particular period of time. So there is also a command to see all the details, but this is mostly used only for admins. But just to give you an example of how what is being calculated, you use share to see the shares. You can see, for example, different users here, and this is the normalized shares that we get. So, for example, I mean, this group in particular has 0.5, meaning that it's going to use 50% of the time. And then each individual users, because the list is longer, okay? So basically has 0.08 and 8% of 8% of this part. Okay, doesn't matter the numbers in particular, but basically it means that here all the users start with a same share of the machine. And what the system is going to do is basically every time you run something, it's going to keep track of that in raw usage. Then effective usage is just a sort of percentage. And then the important thing is the first share. So at the end, it's going to calculate a number based on the proportion that you should get and what you have used. And it will calculate a number that will basically say whether you are above or below the target. Okay, so for example, in this case, we are all really above. basically means if the first error is above 0.5, then it means that you have used less than what you should have, and then it will give you more priority. If your first error is smaller than 0.5, it means that you have used more than what you should have, and the lower the first error, the lower the priority. So it's very simple. I mean, in this case, because we all are assuming that we get the same amount of time, I have used the higher amount of hours, so I get the lowest first error. Basically, that means that if I submit a job, if we all submit a job at the same time and with the same characteristics, etc., I will get less priority because I have used more than the others, so it will put me at the bottom of things. And first error will come later as well because it's really important. The other factor that I was mentioning that we can use in multi-factor is the job size, okay? And this is important as well. I mean, the idea is that in principle we want that the larger the job, so if it asks for a lot of CPUs, then the job size factor, so in reality the priority will be higher, okay? And this is the default in Slurm. There is one configuration that says priority favor small, so in principle we always put it to no. I mean, we could reverse it, but in principle this is the default. And it makes more sense because I mean, this is just a sort of a graphical situation. If you give priority to the small jobs, then they can fill the whole thing. There is no empty places, and then the big job comes and it will leave a lot of holes in there, right? While if you do it the opposite, the big job comes first, then you have empty slots here, and then the small ones can fill in the gaps. So in principle, this will give better utilization overall, but also, I mean, usually we also can run smaller jobs in workstation or systems like Condor, etc. So it makes more sense that, especially in large supercomputers, that we give more priority to large jobs. And so we also have one other configuration that it's small relative to time. This is already in burros, but not in LaPalma yet. The idea is that we want to facilitate debugging or running of a small, very short jobs. So then, assuming that you have the same, that you are using the same amount of CPUs, for example, this job that will take, let's say, 6 days, if you submit another one that uses the same number of CPUs but only takes 1 hour, then that will have higher priority. So if you're trying to run small jobs just to do some tests, etc., then that will give you a boost. And so the CPU efficiency, it's very important as well here, and that basically says what is the, if you ask for 20 CPUs, if you're really using 20 CPUs, okay? And as an avid user could actually trick the system, so you could have a situation like this. So you say, I'm going to use 4 CPUs, but in reality I'm only using 1, because I know that you're going to give me higher priority if I say that I'm going to run with 4 CPUs, and so I want to be higher in the list. But actually, that's why first error is very important, because what we are implementing now is that you are billed for what you get allocated. So if you only are going to use 1 CPU, but you ask for 4, the system is going to keep track that you have used 4 CPUs. So then that is going to impact on first error. So if you have used, as far as the system is concerned, you have used 4 CPUs, and then you have used a bigger share of your share of the machine, and then your priority related to other users will be lower. Okay, so even if you can do it, it goes against you, because it's not, it doesn't matter. I mean, it actually is counting like you're using the whole thing. But it's true that sometimes can still happen accidentally. Maybe you don't know that how efficient your code is or whatever. So the idea is, what we're trying to do is put some tools to help you measure the CPU efficiency. So you can, before you submit a job, you try to check what is the efficiency of the job, and then you try to make it as high as possible, so not to waste any resources. So I mean, the typical ones, you can use stop and hstop, of course, but also there is one command, SF, for Slurm efficiency, and that you run a code, and after it finishes, you run SF with the ID of the machine, and it will give you something like, I don't know if it's big enough. Okay, so at the end it will show you something like this. You can also get this by email. So it will tell you the CPU efficiency of your code. So with that, the idea is that you can tune the code or what you ask for to Slurm, and to make the CPU efficiency as large as possible.
When you say that you get charged for what you get allocated, that applies to time as well. So if you request, say, a day, but you use only 3 hours, does Slurm remember that you use 2 days for computing your priority in the future?
Yeah, no. In this case, no. On that one, for time that will not happen, but because I mean, if you think about it, maybe you ask for 1 day, but at the end you only use 1. And then you haven't really used the rest of the 23 hours. But if you get allocated 4 cores and you use them for 1 full day, in that case you are holding other people from using the machine in the full day. So in this case, it makes sense that you get billed for the whole 4 cores, but not for the whole time. Okay, and then this one is really work in progress. Okay, but it's working okay. And we have this already in Diva. No, in Diva we have another version of this, but this is already in one of the burros. The idea is that we're going to make the same for memory. We can keep the memory as a trackable resource, because as I said before, in LaPalma, for example, you get allocated the whole node in principle, right? Except for a small job. So then it doesn't matter. You have the full memory and that's it. But in burros, you are sharing with other people. So if I submit a job that basically start using the whole memory, it can impact negatively your jobs, and it can even bring down the whole system. Okay, it has happened because there's some codes just went crazy and started using a lot of memory, and then at some point the system starts swapping. It brings down the services like NFS or whatever, and then the whole thing goes down. So we have to try to control that, otherwise the system can become unstable, and we have to restart it many times. And also other jobs will get penalty because suddenly they will start swapping and stuff. So what we're going to do is the same idea as for the CPUs. What we can do is we take the whole memory, and by default, each CPU, and if you don't do anything specific when you ask for time in a Slurm, each CPU will get this total memory divided by the number of CPUs. So if there are 10 cores and 10 gigabytes, then by default, each CPU is allowed to use 1 gigabyte of memory. Okay? But then the good thing about this is that we can do this separately. So for example, here is the same graph as before, but I don't know if it's going to become clear, but I made like a CPUs and memory, okay? And you're going to get billed separately for each of them. So by default, for example, in this case, if there are assume 4 CPUs and 4 gigabytes, if you don't do anything, every time you ask for 1 CPU, you will be given 1 gigabyte. But you can change that. So for example, using just mem per CPU or mem, you can say, for example, okay, this, let me see if I can make this clear. This job, the blue one, is using only 1 CPU, but it's using 3 gigabytes. Okay, so then you will get charged for those 2 things at the same time. So imagine each unit is to pay 1 coin. So the blue job will get charged like 4 coins, 1 for 1 CPU, 3 for the memory. The red one will get, this one is using very little memory, so it can run 2 CPUs, but actually only 1 slot of memory. So in this case, this will get charged 3 coins, okay? And the green one, for example, here is just 1 and 1. The idea is that this way, the memory will also be controlled. So the Slurm is not going to allow jobs to go above the available memory. And also, the same as before, yeah. the same as before. Now memory efficiency becomes very important. It's important that you try to say more or less exact, well, not exactly, but try to give a good estimate of how much memory your job needs, okay? Because now you get in charge for that. So it's the same as before, as the for CPU efficiency. You could trick the system as well. You say, okay, I don't want to compete with other jobs, so I'm going to run one CPU only, one Python code, but I'm going to use the 64 gigabytes of the system. But then you're going to get charged for it, and then your priority will go down. So it's also interesting to try to get closer to what you really need. Well, the rest is the same as for CPU memory, because I think I'm going too long. So, but just asking for memory, this is very simple. So if you see in this case, for example, the only thing you have to do is to add this mem, okay? Because we're assuming we only want one CPU, for example, one Python code. But then for this code needs a lot of memory, so I'm asking for 10 gigabytes, okay? So then the system will give me a big portion of memory, but only one CPU, and then you can control it like that. So you have both mem per CPU or mem. So mem, it would be just in case you know that the whole code needs 20 gigabytes, but in some cases you actually need, you know how much memory you need per CPU. So then it's easier to specify it with mem per CPU. And with that I think I'm going, yeah, definitely too long, sorry. So then for future of Slurm at the IAC, I mean, we have limited computing resources, and it's going to be like this for the foreseeable future. So we need to have a system, something like this. Otherwise, it's difficult to coordinate all the different users, and actually it's even counterproductive, because the jobs will at the end run slower, you run out of memory, etc. So we have to do it. And in that case, because we are obviously not going to decide who runs for how long, etc. First share is essential. You can just give the same amount of time in principle to every users. If you have a particular machine, you can configure to allow different shares. So you can say, okay, this project has paid for 80% of the machine, the other project has paid only for 20, so you can adjust that. So the users of one project can get more shares than the other. First share is also very important because it discourages abuse of the system, okay? Because you're going to get a bill for what you really say that you're going to use. It doesn't matter if you really use it or not. So it's your responsibility to try to stay within the limits, and it will be better for you in the long run. And so, well, I plan to write better documentation of these three things to actually give some indication to users on how to use it, on how to adjust the time, the CPU, and the memory that they request to actually make it more efficient. There is one tool that I think is going to be very nice for that, because it's called report SEF, report Slurm efficiency, that it will give you something like this. Okay, after you run a number of jobs, or only one or whatever, you can say, for example, in this case, I am saying just show me all the efficiency of all the jobs that I run in the last day. So it will tell you the time efficiency, CPU efficiency, and memory efficiency of each of them. So the idea is that you try to stick to the green. If you stick to the green, then it means that these are good numbers, and then you're making use a good use of the burros. Well, the burros or LaPalma or whatever we install this. We are also planning some other improvements. Let me skip this, but maybe interesting is just that deimos and diva, we're planning to separate them, because if we follow this strategy, we don't need a login node. It's working quite well so far. But we also need to study properly how to make the GPUs also under control of Slurm. And we're also planning to do some, like a dashboard, but for all the burros, etc. But let me skip that. I already talked for too long. And so as a conclusion, and I finish, Slurm basically, I mean, obviously is going to stay in LaPalma and any supercomputer that we have access to. And in burros, whether it stays or not, well, it depends on how users take it. I mean, for them, it's true that the users need to change their usage habit a little bit. It's not going to be the same as just connecting to SSH and but it's not very far from it. I mean, with the command sinter, very similar, but it's true that it's a little bit different. But so far, we actually have positive feedback. It improves the resource utilization. I wrote here in most cases. I should really wrote in all cases. I think I was being conservative. And there's several improvements planned for LaPalma and for the burros as well. Here you have the documentation basically to get a start. And as I said before, there is also a channel here in IAC that is meant to anyone who start with Slurm or has questions, suggestions, or whatever can post them there. And sorry I went too long. But, I didn't realize that I have more slides that I should. But with that, I finish. I don't know if there are any questions here or online. I would be happy to take any.
Any questions? Okay, Andrea?
Yes. Can you hear me?
Yeah, perfect.
Okay. Thank you for your presentation, and especially the last part has been useful. I wanted to ask about the job arrays. So I'm a big fan of job arrays. Is it possible to have the job arrays be independent on each other, sort of a pipeline?
Be independent on what? On Java?
No. Being like, I submit a job array, okay? So I have, like, let's say 10 jobs in Slurm, and I will what I would like to do is to have, let's say, number 2 that depends on number 1 and number 3 on number 2. So that they start only when the previous one is over.
Within the same job array?
Yes, for example.
I'm not sure about that because obviously, I mean, with different jobs, whether it's a job array or different regular jobs in a Slurm, you can put the dependency after command. But for jobs that are inside a job array, truth is that I don't know. I will have to check the documentation, or I don't know if...
Okay, so up to now, I just forced the job array to say, okay, just execute 1, and by default, it starts with the lowest number, so that was working. Yeah, but I was wondering it was a better way.
Sorry, go ahead.
I was wondering if it was a better way.
Let me check. I will check the documentation, but because it's true that when you specify the job array, you say, for example, from 0 to 99, and then it will start with the lowest number, but it doesn't guarantee that it will start one after each other. There are no dependencies, but maybe there are.
Okay.
I will check the documentation later, and I come back to you if I find something.
Okay, thanks.
Anyone else?
Just one from the burros usage. When I ask for, if the burros has like hyperthreading, when I ask for a certain number of nodes, it is for threads or just nodes? Because I don't know if I am misusing in that program. I mean,
you can do both things really, and at the beginning I was doing it differently for the different configuration for the machines and have a hyperthreading activated and different, but it was a mess. So to make things simpler, now basically you are counting hardware threads. So the unit here, that's why I put CPU. That's what Slurm calls it. Okay, it's not. But I don't like how they call it, but that's how Slurm calls it in the documentation. For them, CPU is whatever processing unit you get, either a core or a hardware thread. So in the machines that don't have a hardware thread activated, a CPU is basically equivalent to a core. If you have hardware thread activated, when you are asking for 4 tasks, you are asking for 4 hardware threads.
A question that I had is regarding the limitations to the number of jobs. So, for example, if one, I think it's related to this previous question of job arrays. If I tried, for example, to send, if I have, say, 20,000 jobs, and if I try to push it in, I think that can cause some troubles from experience.
Yeah, I mean, actually, recently we limited the amount of jobs that you can submit in one go. In LaPalma, for example, I think now we put it too low. But it's the same as, if you know, the Condor system is basically the same. I mean, when you submit, you have to think that at the moment you are putting a lot of burden on the machine that is taking all those jobs and put it in the database, etc. So normally we put a limit because otherwise the load in that machine will go very high. So in Condor, for example, I think by default is 10,000 jobs, just because when you submit, the process is going to wait. I mean, not to wait, but it has a lot of work to put all those in the database, in the queue, so it can actually bring the load of the machine high and impact other users. So the same here. I mean, if you submit something 20,000, I mean, you can exhaust maybe the other type of resources, but even if you don't exhaust them, it will take a lot of time to process all of them, and maybe it will impact. So normally you put a lower limit.
And the solution is for me, for example, to merge those into fewer, bigger jobs, or can I use job arrays to handle that?
Yeah, I mean, well, the job arrays, no, yes, because with job arrays, you can, for example, say, okay, my job is going to be 10,000, but actually at a given time, I only want to run 100, for example, something like that. But that's more at the running time, not at the submission time. At the submission time, I think probably if you do, instead of submitting one, I mean, if you sort of make sure, for example, that each job is like 16 individual jobs. But like you submit one job, it goes to a node, and when you go there, you actually submit 16 processes. That will be much smaller load than submitting one per. So you can do it with job arrays. We can also do it with GNU parallel, for example. I'm quite fond of GNU parallel. So you could say, okay, I want 10 nodes, and it's only one job. But then GNU parallel, for example, internally will later go and fetch a job when you need it and execute it, sort of like Condor, but internal to one single allocation.
You mean to work to handle the cores within one node?
No, even in several nodes. So, for example, with Slurm, you can say, okay, I want 4 nodes, and then with GNU parallel, you can say you can get a list of all the CPUs and all the nodes that you have available. So GNU parallel later can actually handle jobs to each of the nodes. But then you have only one job, so you will not put any load when submitting. We can check if you want.
Okay.
So on LaPalma, you said that you have this SQ all, but I think it should be a default option for all the super machines. For example, on Pitline, if you type just SQ, it shows you all the users, all the queue. While on LaPalma, it always shows your users. So I thought that it was already configured for LaPalma only. And then you're saying that you write a script that shows the queues for all of them.
I mean, the thing is, this comes from, I mean, we can change it, but the thing is that the LaPalma is not only our machine. Yeah. So the point is that, where is it? Here. Basically, the people at BSC and for the whole Spanish supercomputer network, basically they, for data protection issues, so for just not picking on what other people are doing, they prefer that you don't see the username and other jobs, so that this is okay because there is no information on who is using. But for data protection issues, you are not supposed to know, okay, this particular person is running how many cores, how many nodes. So we cannot do much there because it's meant for the whole rest.
I was just surprised, for example, fill time, you can pick.
Yeah.
And another question about efficiency, about priority. Is there any period for what you calculated it? I mean, is it like 1 month or 1 year or some term? I mean, when you calculate priority for a user or a job?
I mean, you have several ways as well. For example, in LaPalma, if I remember correctly, you discard all the information that is longer than a month. Okay, so
it's like keeping track of last month.
Yeah, but you can also do it, and instead of that, is like a decaying function. So it just you take whatever you consumed yesterday has more importance what you consumed 2 days ago. So it slowly decays, and then that way, if you have consumed something that I think I prefer. So for example, for the burros, I'm configuring it like this. So it's a decaying function. So it gives more important not only to the total amount of hours that you have used in the last month, but if you have used it more yesterday, then I will get more priority. I mean, not necessarily more priority than you, but I don't know if you understand. I mean, it would just give more importance to whatever is more recent to calculate the priority.
Okay, and another question I had was in one of your latest slides, you had talking about the efficiency. You had a table, and in the reports you get information on the memory efficiency and this one and the CPU efficiency. Is this defined as you did early on in your talk? Like the ratio between what you get from what you ask for?
Yes, I mean, this is basically the time efficiency. For example, if you get 100%, you ask for 2 days and you consume really 2 days. That's a ratio of everything.
Okay, but CPU efficiency means
CPU efficiency. You ask for 1 core, but then obviously if your command is asleep, you are not using any CPU. So the computer will actually see how much time you have been using 100% of the core. So if you submit something that only uses 50% of the core all the time, your efficiency will be 50%.
And memory, for example, if you have, I don't know, 32 gigabytes in your node, but your code only uses half of that, it will be 50% efficiency, which will be fine, right? But the other half of memory will be idle, but it's fine because.
Yeah, but I mean, in here with this, the idea is that you are able to put less memory than I mean, in LaPalma, because you use the full node, it doesn't matter. But in the burro, for example, you can say, okay, I want the 4 CPUs, but only half of the memory. In that case, it's not really efficient from the point of view of the system, because if you are using the 4 CPUs, no other job is going to be able to run at the same time. But imagine that you say, I want to run 3 CPUs and half of the memory. So then another job could come that uses the remaining CPU and the remaining half memory. So then you can actually fill everything as better as possible.
Okay. There are no more questions here online. We can finish here. Thank you again, Ángel, for this nice seminar. Thank you.